Okay, so we decided to do our own Eratosthenes experiment by triangulating the sun in two different locations. Okay, let's see what we came up with. So we made our own right angle triangles so we can measure the shadow to come up with the angle to the sun. We did one in Florida and we did one in Michigan, 1,150 miles apart. Pretty easy with the cell phone. We both took our measurements at the exact same time, 12/27, February 13th. So here's Michigan up here, and Florida right here. If we wait till noon, the sun is going to basically be in line with both of the two positions. So we're going to end up with something like this. So here's Michigan, and then we should be able to calculate our distance to the sun, right, on a flat Earth and on a curved Earth. Okay, so here it is on CAD. We're going to do it on a flat Earth first. And the top orange line is from Michigan to the sun, which is 3,154 miles. And that's on a 34-degree angle. And then the second line, orange line, is from Florida to the sun, which is 2,291 miles. And that's on a 50-degree angle. And from the sun to the ground is 1,760 miles. And then from Michigan to the sun on the ground is 2,617 miles. Okay, here's our flat Earth map, and this is the path of the sun in the summertime, right here. This is the summer solstice. This is the equinox right here, and then this is the winter solstice, where the sun takes a long path around. Now, I lined up the sun from the south because we did it at like 12/27. So the sun will be roughly in the south right here. And right here, this is the shortest day of the year if you're in another hemisphere right here, December 20th. We're going to come up to January be about here, and February be about there. So the sun should be pretty close right there. Okay, now here's the bottom of Michigan. It's a few degrees down from the latitude line. So we're going to measure down. We're going to go, every latitude line is 15 degrees. So we're going to come down to here. This will be 15. And then we're going to come down to here. This will be 30. 30 right here. Come down to here, it'll be like 45. And a couple more degrees, 47, we'll say roughly, is where the sun is on this map. So let's take a look. First off, every degree on this map is 59 miles. So 47 degrees times 59 miles is 2773, which is pretty close to our triangulation. So that's pretty amazing. I can't believe it came out that accurate. Okay, here's the globe model. We set the diameter at 7917, same as the globe's supposed to be. Then we left the flat Earth model right on top because the line from Michigan is the same. That doesn't change. And then the yellow line down here is the measurement of the Florida line. Now, according to our calculations, the sun is only 8,000 miles away. Using our numbers, the Earth would have to be much bigger in order for the sun to be millions of miles away. Apparently, Eratosthenes did a much better job than we did without a cell phone or a computer. Now, I'm not making any claims here. I would like to turn this into a workshop. Well, I'll call this part one. And maybe some other people can help me triangulate the sun in different areas. And then we can come up with some calculations, some coordinates, and apply them to a flat Earth to see what we come up with. I don't think anybody's really done that. Now, I'm only off 100 miles. In Michigan, I forgot the 600 foot of elevation. So I moved it up and I picked up another 60 miles. And now I'm only off 100 miles. So, I mean, pretty close. It'd be interesting to see with some other numbers what we come up with. What do you think makes more sense? That this sun is 3,000 miles away or 93 million miles away? I'm going to go with 3,000. Okay, which model do you think makes more sense? Here's Michigan in the wintertime. The Earth is tilted back at 23.4 degrees. Now, here's this angle. Now the sun is actually There's the angle right there. The sun is actually 3 million miles closer. Okay, versus the wintertime, which is the axis going the other way. And here's the angle of the sun. Supposedly this sun angle, now the sun is actually further away 3 million miles. So this angle difference is going to make the difference between summer and winter. As compared to this model, okay, let's look at this model. Here we are in Michigan, right here. And here's the sun. So the sun is out here in the wintertime. And in the summertime, it moves a couple thousand miles closer. And I guess it would make it hotter in the summertime. Which one do you think makes more sense? So if anybody out there wants to help us triangulate a few different positions, let us know in the comments. All you have to do is set up a 90-degree sundial, make sure it's level, and then we can measure the shadow angle, and we'll calculate the angle like we did on this one, and then we'll put it on AutoCAD. Triangulate it from 2 or 3 positions at the same time and put it on AutoCAD. I look forward to hearing from some of you out there. Leave a message in the comments.